So now that we have a general idea of linear functions, we're going to look at some linear functions in the case of word problems. So Lucy wants to track the distance she has traveled over a particular trip. She begins tracking the trip, and she knows that she has already traveled 300 miles. She also knows that she is going to travel 50 miles per hour over the course of the trip. Write a formula for the number of miles traveled m as a function of the hours since Lucy began traveling t. So just instead of f of x, we should probably note that we're using m and t, where t, our time, is our input, and m, our miles, is our output. So let's think first, what would be the slope here? Well, we know the slope corresponds to each additional input, how much change will we get? So we know each additional hour, or t, increases our distance by 50 miles. So I'm going to say that's 50 t plus our y-intercept is our initial value, which in this case, when did she start tracking, would be at 300. So 50t plus 300. So now we could do is plug in any number of hours t, and we can tell how far Lucy has traveled. So what we're saying here now for part B is that we have a graph of her miles and the number of hours. And so the two key aspects are obviously the slope and the y-intercept. In this case, from the graph, I can recognize the slope. As for each additional hour, how much has the distance changed? Well, if at 0 hours, she's at 300 miles, at 1 hour, she's at 350, at 2 hours, she's at 400, we should note that the slope here is 50, which matches our function, that she is traveling 50 miles for each hour. The y-intercept corresponds to the initial value, meaning when she has started her trip, how far has she gone? In this case, that would be 300 miles. So this slope, I would say the units are in miles per hour, and her y-intercept is 300 miles. So now we've got a function and we've understood the graph. We can pick any number of hours and state how far Lucy has traveled. So if we want to know how far she has traveled after 7 hours, we want t to be 7. In other words, we're trying to figure out what is m of 7. M of 7 would equal 50 times 7 plus 300. Or m of 7 would be 350 plus 300. M of 7 is 650. What this is saying is that after 7 hours, Lucy has traveled 650 miles. Margaret is Lucy's friend, and she is also traveling. Margaret has traveled 100 miles at the same time as Lucy began tracking. Margaret is traveling at 60 miles per hour. Write a function for the number of miles Margaret has traveled and determine when she will have traveled the same distance as Lucy. So let's first come up then with a function for Margaret. If we use the same notation, the miles is a function of time. The difference here is Margaret is traveling 60 miles per hour. So I would say that's 60t plus her initial value. She begins at 100 miles. So we have Lucy Lucy's function is m of t equals 50t plus 300. And what do we want? We want these two functions to be equal because that will tell us when these two have traveled the same distance. So we want to solve 60t plus 100 equals 50t plus 300. And what we've got here now is just a basic linear equation. And we want to solve for t. So what I would say we could do is move this 50t over by doing the opposite of it, or subtracting 50t. So 10t plus 100 equals 300. Continuing on, if it's plus 100, we would subtract 100. So 10t equals 200. And if we divide by 10, t equals 20. So what does that mean? That means in 20 hours they will have traveled the same distance. And we could actually figure out what that distance is by plugging 20 into either one of these, and we should get the same answer. So let's say we picked Margaret. If we picked her function, m of 20 would equal 60 times 20 plus 100. So m of 20 equals 1200 plus 100. M of 20 equals 1300. What this means is after 20 hours, they have both traveled the same distance, which would be 1300 miles.